Okay, so we've looked at solving for sides. We've looked at solving for angles. With word problems, we can do one or the other. Okay, it could be either could happen. We just have to figure out what the word problem's saying. Now, all of these have pictures for you because it's notes, but you won't always have a picture, and it might be beneficial for you to draw a picture. Okay, so you can label your sides. So first things first. SOHCAHTOA is still in effect. I like to have it. You don't need to write it if you don't want to. Okay, but it's nice to have. If we end up solving for a side length, just so you know, we're going to round to the hundredths. And if we're solving for an angle measure, we're going to round to the nearest degree. Because I don't think it says that in any of the directions. But that's just going to be our rule of thumb. How do I know what? Okay, so let's just look at the warm-up real quick. If my variable is literally on one of the sides, you're solving for a side. If your variable is where an angle should be, you're solving for the angle. Okay? All right. So the stringer that supports the stairs makes an angle of 50 degrees with the floor. It reaches 3.2 meters up the wall. How far is the base of the stringer from the wall? Okay, so it's already all given to you. Before we even solve it, when you have problems where you have to write or draw your picture, you need to be very careful about information they give you. So for instance, we make a 50-degree angle with the floor. Where is the floor located? Okay, I know you say that, but someone's not going to do this right. The floor's like on the ground, right? It's that base part. Someone's going to mess this up. They're going to put it somewhere else. So the floor is what you stand on, so your ground. So if it's making an angle with the floor, this is your floor. You laugh, but I promise that someone's going to give me something crazy. It happens every year. Okay? Here's my wall. The string goes up 3.2 meters. So if I were to label this information, what am I solving for before I even do any labeling? A side, right? I have this side X. So here's my reference angle at 50 degrees. I have the opposite and the adjacent. So opposite and adjacent give me tangent. So the tangent of that angle equals the opposite over the adjacent. What type of problem is this? It's your division because the variable's on the bottom. So this is your flip and divide. So x equals 3.2 over the tangent of 50. And because we are solving for a side length, we're rounding to the nearest hundredth. So plug that into your calculator. What do you get when you plug that into your calculator? 2.69. Now, just like before when we were dealing with word problems, I made you have a word in your answer, so we need to have our units. What units are we talking about? Meters. Okay, so it is no different than what we've been doing. Number 2 is always my favorite problem, and this is where people definitely mess up. So, a ramp has an angle of inclination, okay, that's just, it's elevated, of 20 degrees. It has a vertical height, so vertical is straight up and down, of 1.8. What is the length of the ramp? So the only thing that's labeled here is that 20-degree angle. Where would I put 1.8 meters at? On the opposite side, right? It's your height. It's your vertical. This is always my next favorite question. What is the length of the ramp? Where is the ramp located? Where's your ramp? The hypotenuse. This is a ramp. Okay? Wheelchairs, strollers, I don't know, bikes, motorcycles go up a ramp. This is your floor, your ground. Okay, so this is the ground. This will always be your ramp. There is a problem like this on your test. I know there is because I put it on there specifically. And half of you, because you're not paying attention to what I'm saying, will tell me this length here is the ramp. Okay? Wheelchairs, this would not be a ramp. A ramp helps wheelchairs or strollers or bikes go up to something. So make sure you know this is the ramp. Once you know that, the setup is the same. So what information do I have? The opposite and the hypotenuse, which is sine. So the sine of 20 degrees equals the opposite over the hypotenuse. What type of problem is this? A division. So flip and divide. What do you get rounded to the nearest hundredth? 5.26 meters. Okay, so the next problem has a lot of information in it. So let's go through this slowly. Any questions on the first two? No? Okay. So, two students want to determine the heights of two buildings. They stand on the roof of the shorter building. So the student is standing here. The students use a clinometer to measure the angle of elevation of the top of the taller building. Where I stopped reading. Where am I at? Top. Okay. The angle is 44 degrees, so it's already in there for you. So they're standing here looking at the top of this building, and that angle is 44 degrees. From the same position, the students measure the angle of depression. Okay, angle of depression is just you looking down. So they're looking down at an angle of 53 degrees. The students then measure the horizontal distance between the two buildings. The distance is 18 meters. The students drew this diagram. How tall is each building? Okay, this 18 meters is in kind of a crappy spot. Let's take it out and make sure it looks like it's this distance here. It is not that angle. It is the distance from one building to the other. Okay, it's not centered very well, so I'm going to move it. Now, before we solve this problem, I want you to flip your paper over and I want to talk about angle of elevation and angle of depression real quick, just so we can see what it means. So draw a right triangle. Okay. Now, if I am a person standing on the ground looking up at an airplane. Okay, so I'm here looking up at the airplane. This angle here is my angle of elevation. Okay, that angle is the angle of elevation. Now, this airplane, someone is looking down from this airplane to me. This is the angle of depression. Okay, so angle of elevation, I'm looking up. Angle of depression, I'm looking down. Now, you're standing on the ground, and theoretically, as long as there's no like turbulence, the plane is flying horizontally, right? Like it's going in a straight path. These two distances, so the ground and that path of the plane, are going to be parallel to each other. Do you agree with that? Yeah? Now, if I have two parallel lines, and I can call this my transversal. We talked about this in the last unit. Is there anything you can conclude about the angle of depression and the angle of elevation? Why are they the same? What type of angles are they? Think about your angle pairs that we talked about when we had two parallel lines cut by a transversal. What type of angles are these? They're congruent. They're the same. Alternate. Are they on the outside? No, they're on the inside of those parallel lines. Do you see that? So the angle of elevation is going to be congruent to the angle of depression. That is going to be helpful for you in some of these problems. So the angle of elevation is congruent to the angle of depression. Here's why it's helpful. Okay, in this case, here's my triangle, right? Now I can either create another triangle to give me side lengths that I need, or if I know these are going to be the same, I'm going to put my angle here and use the information for my side lengths. And you'll see problems like that. But just know if you have an angle of depression and an angle of elevation, they are the exact same. They're going to be congruent to each other. Okay? All right, so let's go back here. So we want to know how tall each building is. So I'm going to call this small building X. For now. Do I have enough information to solve for the height of the small building? We say no. Okay, so let's think about it. This is the side length I'm looking for, right? I have this length, so what do I need to solve for it? I need an angle. So there's no angle in this triangle, right? But what did we just talk about? We just said that the angle of depression is the same as the angle of elevation. Isn't the angle of depression 53 degrees? Which means my angle of elevation is also 53 degrees. Do I now have enough information to solve? Yeah. So what sides do I have if 53 is my reference angle? I have the opposite and the adjacent, which is tangent. So the tangent of 53 equals the opposite over the adjacent. What type of problem is this? It is multiplication. Your variable is on top. So x equals 18 times the tangent of 53. And because we're solving for a side length, we are going to round to the nearest hundredths. What do you get? Yes, Mackenzie. Why didn't I put my variable on the top? So, because we need to know how tall each building is, so eventually I'm going to figure out the height of this building, but I need to know this one first. Or I have enough information to quickly find that one first. What'd you get when you plug that into your calculator? Okay, so 23.89. And just so we know, I'm going to label that BE as well, so you know it's the height of that piece. Are you okay with that? Okay. So there's my small building. Now let's process through what information I need to find the height of this building. Is there any piece that I know from this building? What do I know? I know DC. I know from here. That's not a very good thing, but I know from here to the bottom. Why? It's the same height as the short building. Do you all see that? So I know that this piece, let me do that like this. This piece here is 23.89. So what do I really need to find? I need this top piece. I need AC. Okay, so I'm going to put my Y over here so we can see it. So I'm looking for AC. I know this angle's 44 degrees. Do I know anything else about that triangle? What do I know? The distance between the two buildings is 18 meters. right? Because it was 18 meters here, so it's still going to be 18 meters up there. I mean, unless your buildings are crooked, but hopefully they're not. Do you have enough information to solve for now AC? Okay. What two pieces do I have? The opposite and the adjacent again. So tangent. The tangent of 44 equals y over 18. This is a multiplication problem. What do you get when you plug that in? 17.38. Is that the height of the tall building? No. And hopefully you realize that right now the short building is taller than the tall building. So what do I need to do? Add the two together. So I need to take 23.89 and add it to 17.38, which means the height of the tall building is what? 41.27. So there might be times where you have to look at the word problems and figure out what information you do know, what information you need to find. But once you have it kind of set up and you know what pieces you need, the setup's exactly the same. Okay, so here's what I want you to do. Number 4 kind of has the same idea as number 3 in the sense that you need to find other pieces before you can find the length of AD, which is here. I want you to either work by yourself or work with your group, and you may struggle through this a little bit, and we'll go over it, but see if you can find the length of AD. So figure out what you know, what you need to find, and see if you can process through that. I will tell you, you will have to do 2 separate trig functions. Okay, so you'll have to kind of do exactly what we did up here. So figure out how you can find that length. Okay, so I'm going to give you a few minutes to kind of struggle through that with either by yourself or your group. Okay, so I talked to a group, and the issue is they can't find this side because they don't know either of these 2 sides, right? So I'm going to ignore this triangle for a second, and I have one side in an angle. I either need to find AB or AC. Which one should we solve for? AC. Why AC? Because it's connected to the other one. Exactly. So I want to find AC because it's then attached to this triangle here. So once I know that side length, I can find this one. Okay? So if I'm looking at 46, this is my adjacent, and this one is the hypotenuse. Right? Adjacent and hypotenuse? Which one do I use? Cosine. So the cosine of 46 equals the adjacent over the hypotenuse. What type of problem is this? Your flip and divide. So 55 over the cosine of 46. And when you solve for y, what do you get rounded to the nearest hundredth? 79.18. Okay, that's AC. That's what AC equals. Are we okay with that? Yeah? Now, since I know that this is 79.18 and I know this angle, can I solve for that side? Can I solve for my x? So I have the opposite and the hypotenuse. Which trig function uses opposite and hypotenuse? Sine. So now it's the sine of 55 equals the opposite over the hypotenuse. Again, it's a flip and divide. And what do you end up with for the length of AD? X equals 96.66. Okay, so think about information that you know and think about information that you need to find. Because once you figure out kind of what sides and angles you have, the math part is not hard. But you have to know what it is you need and what it is you're looking for. Questions, comments, or concerns?